my name, Ahmad Nazirul Atif bin Abdul Basit.
My name is Fitri Zulaika binti Muhammad Yusri.
My name is Nur Farah Azwania binti Syafi'i.
My name is Nurul Alia Natasha binti Muhammad Milam.
My name is Siti Nurhaira binti Azhar. And we are going to present past year question April 2008, question 3 and question 4.
So I will discuss for question 3A. The question is construct a PERT network for the project. Okay. First we draw node number 1, and for activity A and activity B there is no predecessor, so we draw a straight line from node number 1 to node number 2, and it will become activity A, 3 weeks. Next, we draw a straight line from node number 1 to node number 3, and it will become activity B, 5 weeks. Next is activity A to C. Right here, we draw a straight line. Activity A, from A, we draw a straight line first. This line will be activity C, 3 weeks. And next one is A and B to D. A and B to D. There's no possible way from A to D, so it will become a dummy one. For right here, B to D. From B, we draw a straight line, and this line will be activity 3 weeks. Next is B to E. B to E, right here, from node number 3, we draw a straight line, will be activity E, 2 weeks. Next is C and D to F. So right here, we previously we draw this line, so we'll make a node number 4 right here. Node number 4. This node, we draw a straight line, and it will become a activity F, 1 week. Okay, next one is C and D to G. Right here, we draw a straight line. Draw a straight line first, and this line will become activity G, 3 weeks. Next is E and F to H. Right here, E, previously we already draw this line and also this line. So next we'll make node number 4 and node number 5 right here. Node number 5. So this node is for E and F. So E and F to H. So we will draw a straight line from node number 5. Draw a straight line right here, and it will become activity H, 2 weeks. Next is G to I. Okay, previously we already draw this line, right? G. So we'll make node number 6 right here. Node number 6. Okay, as you can see, from G to I right here. G to I. Okay. Next, and the last one is G and H to J. G right here, H right here, node number 7, H to J. So there's no possible way from G to J, so it will become a dummy 2. G to J will become dummy 2. And then H right here, H, we draw a straight line from node number 7 straight to the node number 8 right here. So this line will be activity J, 4 weeks, and previously we draw this line, right? And so this line also end at node number 8. So this line will become activity I 5 week. Okay. Now we already draw our PERT network, and this is how our PERT network gonna be. There's 2 dummy in this PERT network. The first one is right here, which is from A to D, and the second one is right here, which is from G to J.
Okay, we move to question B. The question is to determine the earliest event time, which is EET, and latest event time, which is LET. The calculation of EET start at the first node of the network and move forwards. The EET of the first node is always 0. And to find EET node 2, we need to plus the EET node 1 with duration for activity A, which means EET node 1 plus duration activity A, which is 0 plus 3 equal to 3. And the EET node 2 is 3. When there is more than one activity leading to an event, choose the largest value among the alternatives to determine the EET. The value of dummy here is 0, so we need to determine the EET for node 3. EET node 2 plus dummy, which is 3 plus 0 equal to 3, and EET node 1 plus duration activity B, which is 0 plus 5 equal to 5. So we take 5 as the largest number for node 3. Same goes to node 4. There are 2 activities leading to node 4. So EET node 2 plus duration activity C, which is 3 plus 3 is 6, and EET node 3 plus duration activity D, which is 5 plus 3 equal to 8. So the EET for node 4 is 8. For node 5, EET node 3 plus duration activity E, which is 5 plus 2 is 7, and EET node 4 plus duration activity F, which is 8 plus 1 is 9. So the EET for node 5 is 9. For node 6, EET node 4 plus duration activity G, which is 8 plus 3 is 11. For node 7, EET node 6 plus with dummy, which is 11 plus 0 is 11, and EET node 5 plus duration activity H, which is 9 plus 2 is 11. So the EET for node 7 is 11. And last node 8, EET node 6 plus duration activity I, which is 11 plus 5 is 16. And the EET node 7 plus duration activity J, which is 11 plus 4 is 15. So take 16 as the largest number for node 8. Okay, settle for EET, and now we continue with LET. The calculation of LET start at the last node of the network and move backwards. The EET of the last node is the LET of the last node. The last LET is 16. For LET node 7 equal to LET node 8 minus with duration activity J, which is 16 minus 4 equal to 12. When there is more than one activity leading to an event, choose the smallest value among the alternatives to determine the LET. For LET node 6 equal to LET node 8 minus duration activity I, which is 16 minus 5 equal to 11, and LET not 7 minus with dummy, which is 12 minus 0 equal to 12. So LET for not 6 is 11 because 11 is the smallest value. LET not 5 equal to not 7 minus duration activity H, which is 12 minus 2 equal to 10. Like not 4, we have two alternatives to determine the LET not 4. LET not 6 minus duration for activity G, which is 11 minus 3 equal to 8. LET not 5 minus duration for activity F, which is 10 minus 1 equal to 9. So the LET for not 4 is 8. For LET not 3 equal to LET not 4 minus duration for activity D, which is 8 minus 3 equal to 5, and LET not 5 minus duration activity E, which is 10 minus 2 equal to 8. So the LET for not 3 is 5 because 5 is the smallest value. For LET not 2 equal to LET not 3 minus with dummy, which is 5 minus 0 equal to 5, and LET not 4 minus duration activity C, which is 8 minus 3 equal to 5. So the LET for not 2 is 5. For not 1, the LET not 2 minus duration activity A, which is 5 minus 3 equal to 2, and LET not 3 minus duration activity B, which is 5 minus 5 equal to 0. So the LET not 1 is 0 because 0 is the smallest value.
Next, we are going to identify the critical path for the project. To get this answer, students are required to calculating the earliest event time and latest event time. Then we need to identify the longest time path of project to get know the critical path. Based on the question before, we can show that the critical path for the project is 1 to 3 to 4 to 6 to 8 since they have the longer path of project. The next question is determine the project completion time for this project. The answer is 16 weeks.
Question E. Determine the total floats and free floats for activity C and H. What is float? A float is the total amount of spare time for each activity in the network. So, firstly, we calculate the total float for activity C. For activity C, you need to take all the information from the diagram at activity C, and then you need to know the formula of total floats, which is total floats equals to LET in the head knot minus EET in the tail knot minus duration of the activities. In the tail knot, we get EET is 3 and LET is 5. In the head knot, we get 8 for both EET and LET. So, you can take all the information from the diagram at activity C and then put it into the formula. So, you will get 8 minus 3 minus 3 equals 2. So, the answer for total floats in activity C is 2 weeks. For activity H, we must use the same formula of total floats. In the tail knot, we get EET is 9 and LET is 10. In the head knot, we get 11 in EET and 12 in LET. So you can take all the information from activity H and then put it into the formula. So you will get 12 minus 9 minus 2 equals 1. So the answer for total floats in activity H is 1 week. Other than that, we need to calculate the free floats for activity C and H. Formula for free floats is equals to EET in the head knot minus EET in the tail knots minus duration of the activities. Information for EET in LET is the same number at total float. So you just need to take all the information from activity C and H, then put it into the formula. So for activity C, you will get 8 minus 3 minus 3 equals 2. So the answer for free floats for activity C is 2 weeks. Next, for activity H, you will get 11 minus 9 minus 2 equals 0. So for the answer for activity free floats for activity H is 0 weeks.
For the last question, what will happen if activity H revised to 5 weeks instead of 2 weeks? To answer this question, first we need to look at the tail and head of H2. The total of tail is 9 per 10 and head is 11 per 12. After revision, the formula is total float of H, which is LET of H minus EET of T minus duration. So 12 minus 9 minus 5, and the answer is negative 2 weeks. As a conclusion, if activity H is going to delay by another 3 weeks, the project completion time will be delayed by 2 weeks.
Next, we will discuss question 4 in the past year question April 2008. There is 2 questions, which is question A and question B. I will explain about question A. The question is to design an aggregate production plan for a unique garment house that will economically meet demand using constant workforce strategy by varying inventory, overtime, and subcontracting units. So the question tells us to use strategy 5 to solve the problems. The first step is we need to find capacity per quarter. In this question, we find that its capacity is taken from the regular capacity per quarter which has been given in the question, which is 40,000 units. So with that, the capacity per quarter is 40,000 units. Next, the second step is to calculate the total excess, shortage, inventory, OT, subcontracts, and stock up for each quarter. Therefore, we simply solve them in a table in sequence. First, we list the number of quarters and forecast demand that have been given in the question. Among them are for the first quarter of 20,000 units for forecast demand. The second quarter is 40,000 units. The third quarter is 120,000 units. And finally, the next quarter is 100,000 units. Next, for capacity, we take from the capacity per quarter that has been calculated in the first step, which is 40,000 units for all quarters. For the amount of excess and shortage, we need to calculate rather than look at the forecast demand and capacity. If the total forecast demand is lower than capacity, it will be placed under excess. But if the total forecast demand is higher than capacity, it will be placed under shortage. So for the first quarter, we can see that the forecast demand is a shortfall of 20,000 units of capacity, so thus 20,000 units will be placed under excess. The next second quarter found that total forecast demand and capacity were the same, so empty in both. The third quarter was found to have a difference of 80,000 units of total capacity from the forecast demand, thus placing 80,000 units in the shortage section. Finally, for the fourth quarter, there was a shortage of 60,000 units in the capacity division. So 60,000 units were placed in the shortage division. For the inventory section, if the amount is in the excess section, we need to add, but if the amount is from the shortage section, we need to subtract. So for the first quarter, we find it has 20,000 units in the excess section. So we put it in the inventory section of 20,000 units as well. And then for the second quarter, there is no excess and shortage. So there are still 20,000 units in the inventory section because there is no rejection or addition. For the third quarter, there is a subtraction of the 80,000 units. So therefore, 20,000 units subtract with 80,000 units will be negative 60,000 units. So it has to be placed in the OT and subcontract section because it has a negative. Thus, as many as 20,000 units in the OT division and 40,000 units in the subcontract divisions. Therefore, the inventory will be zero. Last time for the fourth quarter had 60,000 units in the short-term section. There was a decline in the inventory section and become negative 60,000 units because zero from the third quarter was rejected by 60,000 units. This made it place in the OT division of 20,000 units and subcontract of 40,000 units. For the stock out part, there is no addition or subtraction there. Lastly, to calculate the total will be added in each quarter for each division. So with that, a total of 280,000 units in the forecast demand section, 160,000 units total capacity, 40,000 units in the total inventory and OT section, and finally a total 800 units of the total subcontract.
So, the last question is compute the total production cost for the year 2008. First, we must calculate the regular production cost. Regular production cost equal to total capacity times regular production rate, which the total capacity is 160,000 and regular production rate is RM200. So, the total of regular production cost is RM32 million. Next, we need to calculate the inventory holding cost. Total inventory, which is 40,000 times holding cost, which is RM50, and the inventory holding cost equal to RM2 million. Thirdly, we need to calculate the overtime cost. The total overtime is 40,000 and we need to times the overtime cost, which is RM300. And the total overtime cost is equal to RM12 million. Next, we need to calculate the subcontract cost. Total subcontract is 80,000 times subcontract cost, which is RM350. And the total subcontract cost is equal to RM28 million. Finally, we need to add up all of the costs we have already calculated, which is regular production cost plus inventory holding cost plus overtime cost plus subcontract cost equal to RM32 million plus RM2 million plus RM12 million plus RM28 million. So, the total production cost for the year 2008 is RM74 million.
That's all from us. Thank you.